Alright, welcome back. We are doing, in this video, the Part A, no calculator, part of the 2013 International Practice Exam for AP Calculus BC. And got 55 minutes, no calculator. I got my timer, I've got my drawing program. I think there's nothing really to do but to begin. If f of x equals blah, then f prime of x equals... Okay, so first thing I noticed is that we might be able to factor this, but it probably won't matter. So let's just compute this derivative by force. So it's going to be the derivative of the top, so 2x plus 3 times x plus 3 minus the top times the derivative of the bottom, which is just 1, divided by the bottom squared. Okay. And so if we get 2x squared plus 6x plus 3x plus 9, and then of course minus this, brings us to 1x squared minus 3x, gets rid of this, and then minus 2 brings us to 7. So that is all divided by x plus 3 squared. So we're going to get x squared plus 6x plus 7, okay, no careless mistakes there, plus x plus, they're divided by x plus 3 squared. So, which answer does this match? Looks like it matches answer C. So at the, very quickly, just being sure that no careless mistakes happened, I'm just going to look at what we did there. Remember, we have about 2 minutes per question here, so, oops. We have enough time to be sure of things like this. Okay, yeah, answer C. And, oh, I gotta pause and write out my answer numbers. Just a second, bear back. Alright, so here we are back, and let's just put down our answer, which is C, x squared plus 6x plus 7, and sorry for getting rid of the work. Okay, and I suppose we can also draw ourselves a little boundary here to define our workspace and our answer space. Okay, perfect. So question 2, the integral of blah equals, alright, so it looks like we are just, okay, let's just multiply this out. So this is going to be the integral of 5, x times the square root of x is x to the power of 1.5 minus, okay, dx, minus the integral of 5x cubed dx. So you could get stuck into trying to do some kind of weird u substitution there, but let's just do this. So here we get 5 times the antiderivative of this, so it goes up to x to the 2.5, so you get x to the 2.5 divided by 2.5, and then there's actually no bounds here. Minus 5 times x to the 4th over 4. All of this plus c. So here we get this equals 5 times, so this is x squared root x over 2.5 minus x to the 4th over 4 plus c. Which answer matches this? Alright, so, alright, well we can... It looks like it might be answer D here. It just all depends on how you're expanding this out. I think that's where they're trying to trip us up. Let's check D. So if we get this 5 coming in here, then we get 5 times x to the 5 halves, so 2.5, divided by 2.5, but 2.5 is just 5 halves. So this cancels out, that cancels out. And this leaves us with this term itself just equals 2 times x to the 5 halves. So it actually is C, 2x to the 5 halves minus 5x to the 4th over 4 plus C, answer C. Again, 2 answer C's in a row. That's nice. Alright, will it let me delete anything here? Okay. Boom. Okay. What is the value of this? Well, this looks to be and alternating series. So let's factor out a negative 3 here. So the term is equal to negative 3 times, now we can just say negative 3/5 to the n. I factored out the 1 there, and n plus 1. And this here is going to come out, so n starts at 1, which means that the first term, or a, is going to be a equals negative 3 times negative 3/5 or a is going to equal 9/5. And every term, r, is getting multiplied by negative 3/5. So the sum up to infinity is going to equal 9/5 divided by 1 minus negative 3/5 is 1 plus 3/5, which is 5/5, plus 3/5 is 8/5. So fifths go away. You're left with 9/8, otherwise known as answer D. All right. Boom. I hope I'm not making careless mistakes here. It looks like we're safe, at least on that one, yes. Okay. Which of the following is an equation of a line tangent to the graph of this at the point negative 1, 3? So, in order to find that, let's find the derivative here. So we get 2x minus, now we got to do product rule, so minus 3y minus, so now derivative of y minus 3x dy dx equals 10. So now we just solve for dy dx, so we get that, so 2x minus 3y minus 10 equals 3 times x equals 3x dy dx, but we can get rid of this here and divide it here, 3x. So dy dx equals this divided by 3x, and so if we plug that in at the point 1, negative 3, that tells us x equals 1, y equals negative 3. So we plug this all in, we get 2 times 1 is 1, minus 3 times negative 3 turns out to plus 9, minus 10 divided by 3 times 1. Okay, so this goes to 11 minus 10, 1/3. That tells us that the slope is 1/3. All right, well, that's useful. So that tells us that y equals 1/3 times x minus 1, which looks like it narrows us down to just one solution, actually. All right, answer C. Looks to be our best bet. Okay, fantastic. We have a lot of C's here, but we can't let that trip us up. Maybe we'll come back to this near the end and see if we're making some glaring errors. If y equals this, dy dx. Okay, so this is just classic derivative problem. So we multiply out the 4/5 x, and we get 4/10 x to the negative 1/5, which is 4/5 minus 1, minus, and then this is really saying the derivative with respect to minus 3 derivative with respect to x of x to the negative 5th. So with this known, we can say that this equals negative 3 times, and then you take out the negative 5, negative 5x to the negative 6th. Yep, okay. And so that leaves us with, if we take out this 4/5, we get 2/5, or 2x to the 1/5, it's another way of writing it, 2x to the 1/5 minus, plus actually, plus 15x to the negative 6th. All right, otherwise known as plus 15 divided by x to the positive 6th. All right, so which one answers this? Looks like C is doing a good job. No, it's not. Looks like D is doing a good job. No, it's not, actually, because the x is on the top. Looks like A is doing a good job. So A says 2/5 divided by x to the 1/5 plus 15 divided by x to the 6th, which looks to be correct. Okay, answer A for C. All right, we got a lot of reds and oranges going on here. Let's switch it up with our color scheme. The graph of the function f consists of two line segments as shown in the figure above. The value of the integral from 0 to 3 of the absolute value of x dx is what? Well, from 0 to 3, we got to consider what these shapes are, but we can't let it being below the x-axis deter us. We got to always be adding it. So this is equivalent to the integral from 0 to 2, and then subtracting from 2 to 3 because it's going to be negative there. So from 0 to 2, let's just calculate that out. We have a box of area 1 here. So I'm doing from 1 to 2. We have a box of area 1, so 1, plus, now we have a triangle of area 1/2, right? Base and height of 1/2, so 1 plus 1/2. That is from 0 to 1. Now from 1 to 2, we have another triangle of area 1/2. Now, don't start subtracting here, this area of 1/2. We must continue adding because it is asking for the absolute value. Therefore, we must add on yet another 1/2 area triangle, which will get us all the way up to 2 1/2. So 5/2. Answer D. All right. I'll just leave that in there. We'll erase it later. Yay. And by the way, you could rule out A and E immediately because it's definitely gonna be defined. And it's not gonna be negative if it's the absolute value of something. Alright. Population y changes at a rate modeled by the differential equation blah equals blah, where t is measured in years. What are all values of y for which the population is increasing at a decreasing rate? So, you need, in order to be increasing at a decreasing rate, you need dy dt must be greater than 0, but also the second derivative of y with respect to t must be less than 0. So let's calculate that second derivative. So second derivative of y with respect to t squared, this is going to equal, yeah, this is going to be annoying to calculate. Should we calculate it? Sure. So 0.2 times 1,000 is 200, so 200, and then y, derivative of y is just 1. Then we get minus 0.2 y squared. So let me just write this out. This is 200 y minus y squared over 5. Right, so then we get minus 2 y over 5. Okay, so it makes things nice. And, or sorry, 2y over 5 dy dt. We got to do the chain rule. All right, and then dy dt, of course, is this entire thing, 0.2y times 1,000 minus y. Oh boy, this is getting useless. There's probably a better way to do this. Let's first rule out all values for which the population is decreasing. So we need where the population itself is increasing. So, alright. Actually, let's just think about this. This is going to be a logistic curve, I believe. So, it's saying that you're always multiplying by the fraction that you have between u and 0 and between u and 1,000. So that's going to look something like at the very beginning, you're going to not have much. Near the middle, you're going to have a lot. And then near the end, you're going to start, this 1,000 minus y is going to start going down. So the population is going to be going at a decreasing rate. Yeah, this is going to be from 500 to 1,000 only. So this is going to be whenever you're on the second half of this logistic curve, so C. Yeah, it's always going to be increasing, but at a decreasing rate only happens for the second half. Okay, and it cannot be E because your population will never exceed 1,000 if you have that that category, or what's the word? If you have that class of differential equation. All right, question 8. And we're making good time, by the way. We should be, if we're spending exactly 2 minutes a question, we would be at 41 minutes, so we're a minute ahead. Okay, well, let's try to put some extra time ahead of us still. So, which of the following is the length of the path described by the parametric equation x of t equals 2 plus 3t, and y of t equals 1 plus t squared plus t equals... Alright, yeah, so basically we need the square of the derivative. So this x derivative, x prime of t equals 3, and the derivative of y of t equals 2t. So when we square those, we get 9 plus 4t squared. We're looking for the integral of this from 0 to 1 dt. So, alright, we got all the integrals dt's. So 9 plus 4t squared, it looks like answer D is calling our name. Answer D. Yeah, none of the other ones make sense at all. Okay, answer D. Let me make that a bit of a better D. There we go. Whoops. Whoops. Haha, finally delete. Okay. Let y equals f of x be the solution to the differential equation. dy dx equals 2x plus y with initial condition f of 1 equals 0. What is the approximation for f of 2 obtained by using the Euler's method with two steps of equal length starting at x equals 1? Okay, so f of 1 equals 0. You can write that out. F of 1 equals 0. That's useful to know. But now we want to get f of 2 with two steps of equal length starting at x equals 1. So we're going to use steps size 1/2. So that tells us that f of 1.5 is approximately f of 0, aka 0, plus 1/2, which is the step size, times dy dx at, it just tells us that at the position 1, we're at 0. It just tells us x equals 1 and y equals 0. So dy dx equals, well, 2 times 1 is 2, plus 0 is 0. Okay, so that just is going to equal 1. Now on to f of 2, it's going to be approximately f of 1.5, aka 1, plus step size of 1/2 times the slope, at the new coordinate, which is 1.5 comma 1, because the y at 1.5 is 1. Okay, so that's going to come into the differential equation. 2 times 1.5, 3 plus y plus 1. So now we get 4 halves, so 1 plus 2 is 3. So approximation for f2 is 3, or D. We're getting a lot of C's and D's. Yeah, this is statistically significant probably, but I don't know. I don't want to doubt myself based on just the answer numbers. It's perfectly possible for that to happen. Although, some A's and B's would be nice in the future. We'll see how it all evens out. The integral from 0 to k of blah is this, where k is more than 0, then k goes... Okay, so let's calculate the derivative here quickly. So, if we... Alright, so we can't factor this. U substitution. Alright, so u is going to equal x squared plus 4. Du equals 2x dx, so dx equals du over 2u. So this tells us that we're going to have the integral from 0 to k of 1/2 times 1 over u du. I'm just doing the division in my head. So this is equaling 1/2 times the natural log of 4. Alright, fantastic. So now this is u to the negative 1, which is going to integral, that's going to be natural logs. Okay, so this is 1/2 times the natural log of the absolute value of 2, which is x squared plus 4, which is always positive anyway, so we don't care about that. From 0 to k, okay. I'm going really fast. I gotta not make silly mistakes. So you want to watch out for those silly mistakes. Alright, cancel those out. So now, finally, we get the natural log. We plug in k, so of k squared plus 4 minus the natural log of k equals 0. So minus natural log of 4, so this corresponds to division. So we get the natural log of k squared plus 4 all over 4 equals the natural log of 4. So e to the x both sides. You get that k squared plus 4, and then multiplying the 4 is 16. K squared equals 12. K equals the square root of 12, or 2 times the root 3. Okay, or just d, root 12. Oh my goodness, I have never seen such a layout of answers. CC, DC, ADC, DDD. Yeah, I'm still going to roll with it, though. I don't think we should give an intentionally incorrect answer just so that we get more varied answers. The third degree Taylor polynomial for the function f about x equals 4 is a huge function. What is the value of f prime prime 4? Well, f prime 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 is with this cubed term, so clearly their cubed term coefficient is 1 divided by 512. So this is not necessarily the coefficient. It is definitely not the coefficient right off the bat, because you got to consider that this coefficient here equals the real coefficient, which I'll call k, divided by 6 factorial. Or sorry, not 6 factorial, 6, or 3 factorial. But that's equivalent to k over 6. So what we really need to do is consider what is this 1 over 512 times 6. So that is, say, 6 over 512, and 6 over 512 is... what is that? Is it 64? Let's consider this. It's not A or B because it's not negative. Yeah, okay. Oh, actually, it's D. Let's just simplify this. This is 3 divided by 256. 256 multiplied by itself is 512, correct? Okay, and 3, and I guess you can't. Okay, so D again. This is incredible, as one would say in Spanish. Incredible. Oh, so many answers that are weird things. As in D. So many answers are D. Let's switch to a new color. Maybe switching to a new color will make it switch answers. Which of the following? For which of the following does the limit of f of x as x approaches infinity equal 0? Alright, well, clearly here, x to the 99th is way faster growing than ln of x. So it's definitely going to be I. It is also not definitely happening for I, for number 2 here, e to the x grows way faster. And finally, for e to the x eventually will easily win out over x to the 99th. So it's x and I. Hey, indeed, we get answer E. Fantastic. All right. This is the type of question where you want to know your growth rates. Factorial beats out anything, by the way. Well, on any of the elementary functions they're going to be using here. The graph of f prime, the derivative of f, is shown in the figure above. If f of 0 equals 20, which of the following could be the value of f of 5? Okay, so what it's telling us is that f of 0 is 20, so we're going to take like the approximate integral here. So we're going to be going up by a lot. Okay, so if we just imagine that this is a perfect rectangle about 3, that would give us an area of 15, so it's going to be answer D. You see what I did there? We started at 20, and then it looks like on average it's about height 3. So if we multiply 3 by 5 to get this rectangle from up at 3 all the way over by 5, you get an approximate integral, right? And you can add that to 20. 15 plus 20 gives you another answer, D. I know. Isn't it great? Okay. And it might trip you up. It's possible the answer is 40, but I really don't think it is, because if the answer was 40, then it would have to be at 4 at all points, which is not. Okay. And it can't really be 25, because, yeah. Okay. Too low. So, yeah, it's D. If A and B are positive constants, then blah, 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 blah equals. Okay. That's nice. So, this is definitely going to be one of those natural log simplification problems. So, so we can pull out these natural log. No, we can't. Okay, yeah. So the limit of x approaches infinity. So the natural log of okay, as x approaches infinity, the 1 and the 3 become irrelevant. So this turns into the natural log of bx divided by the natural log of ax squared. Ax squared turns into natural log of bx divided by 2 natural log of ax. Okay? So if you're taking the limit as this goes to infinity, the a's and b's, so this is a product now? Okay, so this is a product. So this is going to come out to be the natural log of b plus the natural log of x divided by the natural log, 2 times the natural log of a plus the natural log of x. And here what we're going to find is that the natural logs of x's are going to... Alright, well, doing this expansion isn't really helpful. Basically, you're going to be left with b over 2a, otherwise known as 1/2 b over a. So, answer C. Because you won't get 1/2, the a's and b's will indeed affect which side grows faster. And just to prove it, actually, we could probably also use L'Hopital's rule for this. Whoops, phone. Okay. Let's see. If we used L'Hopital's rule, how would we do this? So, just a second. Phone's ringing. I'll pause. Alright, resume. So, if we take the derivative of this, we get b divided by bx plus 1 divided by 2a divided by ax squared plus 3. And if we say this goes to infinity, this goes to infinity, then these are going to cancel out. And yeah, you get 2b over a. Wait, what? Wait a minute. There's something wrong here. Hold up. So here, so then you're dividing by the derivative of the bottom, which is 2a is, oh, yeah, 2ax. Aha. 2ax. So what? Okay. So 3 becomes irrelevant. The a's cancel out. You get... Alright, you know what? I'm considering it. Let's just go with answer C. It's the only one that involves A and B in a reasonable way. Anyway, I'm forgetting. Okay. Okay. You know what? Let's just say if we feel like it, we can come back to this, but it's like a backwards flag because we really don't need it. It's like for kicks if we want to ask about it again. What are all the values of x for series blah converges? Okay. So here, what we have is an alternating series. So if this x plus 3 halves to the n over n goes to 0, it'll converge. So what we're looking for is values for which that'll happen. And that will happen whenever x plus 3 halves is both less than 1 and greater than negative 1. Although, actually, it has to be, it can't be less than 1 because then the alternating series part will go away. Although, actually at that point it'll be the same as, just a geometric series, so it should be okay. Yeah, okay. So what this means is if we shift everything down, we get that x is less than negative 1/2 and greater than negative 5 halves. And it can be equal to these, but it can't be equal to the less than one, but it can be equal to, so it can be this because then it would still have the alternating series if it was negative 1/2, but because then you have alternating harmonic series. If it was negative 5 halves, you would not have an alternating harmonic series. Which brings us to answer B. Hey, 15 questions, first time of getting answer B. That is slightly weird. All right, well, you know what? We don't have as much time as I might like, so let's rock and roll. What is the okay, for P between that, what is the antiderivative of this? Okay, so we do our partial fraction decomposition, and let's just bang it out. A divided by, okay, well, so this is going to be 1 divided by 100, sorry, 1 divided by P times 100 minus P, right? Yeah, okay. So equals A divided by P plus B divided by 100 minus P. So then we multiply by this and we get that 1 equals A times 100 minus P plus BP. So P equals 0. We get that 1 equals 100A, so A equals 1/100th. That's not how you write 100th. And then B, so set P equal to 100, and you get that B also equals 1/100th. Alright, that's fun. That's correct also, right? Yeah. Okay, so that makes sense also. So because of that, you get so you're trying to solve for the antiderivative of 1 divided by 100p plus plus 1 divided by 10,000 minus 100p. So this is equivalent. Oh, and actually, I'll just make it simple for us. This is going to be 1 over p plus 1 over 100 minus p all times 1/100th. Okay, and antiderivative, let's do this quickly. Okay, so it's going to be 1 divided by 100 times natural log of the absolute value of p, and this is going to be minus the natural log of 100 minus p. Yep, okay. And that's chain rule there. Okay, so when we look at this, that we get probably answer A, right? Yeah, answer A matches what we got. 100 natural log, okay. Perfect. Isn't it funny? That's also the first time we've gotten an answer A. So, I mean, there's some weird stuff happening there with our ABCs there. Okay. If the limit of blah equals this, okay. So, it's asking for where the derivative of the arc sine equals 0. Well, the derivative of the arc sine is, like, sorry, where it equals 2. Derivative of the arc sine, isn't it, excuse me, times 1 minus a squared. Yeah. I'm going to flag this so we can come back to it, so we know to come back to it later if we have extra time. But for now, I'm going to go with this, because I don't actually remember if it's plus or minus or what. Equals 1/2. So a squared equals 1/2. Oh, okay. It actually can't be this, because then it would have to equal a plus or minus a fourth. Maybe it's plus then. If it was plus, ooh, then you have a negative. Okay, that's strange. The derivative of arcsine. Yeah, okay, let's just come back to that. The graph of the function f consisting of two line segments, alright, shown above. Let g be the function given by g of x is 2x plus 1, and let h be the function given by h of x equals f of g of x minus 5. Okay, so the value of h prime of 1 is going to be equal to f prime of g of 1 times g prime of 1. So, alright, f is shown above. So, okay, g of 1 equals 2 times 1, which is 2 plus 1, so 3. So we're looking for the f prime of 3. F prime at 3 here is this. So let's calculate the slope quickly. So change in y is negative 6. Change in x is 3, so we get negative 2. Okay, so the slope is negative 2, so f prime at g of 1 is negative 2 times g prime itself at 1. And g prime everywhere is 2, so times 2 is negative 4. A. For answer 18. Yeah, okay. Fantastic. Which of the following is the Maclaurin series for this? Okay, so Maclaurin series, yeah, okay. So we start off with it at 0, so we're going to get 1 over 1. That's good. So it's definitely not E. Then we take the derivative of it, finding ourselves with still, okay, let's just calculate one derivative. So I'm going to do the quotient rule here. So, well, actually, no, it's just 1 minus x to the negative 2. So negative 2, sorry, positive 2 because of the negative in there, times 1 minus x to the negative 3, which is just going to come out to, sorry, this goes to 1, so it's just going to be 2. I see. So basically you're going to have, yeah, okay. And then for the next one, you're going to have plus 6 times 1 minus x to the negative 4th. And then that's going to go away again because x is still 0. So yeah, so but now you're going to be dividing by 2 factorial. So you're just going to have 1 plus 2x plus 3x plus 4x, or sorry, plus 3x squared plus 4x cubed. So it's going to be answer C. Yeah, fairly certain on that. Okay. Boop. Nope. Boop. Okay. The graph of the function f in the figure above consists of 4 line segments. Let g be the function defined by g of x is the integral from 0 to x of f of e. Which of the following is the equation of the line tangent to the graph of g at x equals 5? Okay, so from 0 to 5. Right. So, first of all, for the line tangent, we need the actual value at g of 5 times the slope at x minus 5. So this is what we're looking to fill in. So let's look for g of 5 first. So, g at 5 is going to be, let's just calculate this with our little boxes and everything. So we're going to have, so from 0 to 5. First, we have an area 1 square plus an area 1/2 triangle, so that's 1.5. Then we subtract off this huge triangle, which has a height of 2, so minus 1/2 times a height of 2 times a base of 4. Okay, so 1.5 minus 4 is 3 halves minus 8 halves, so negative 5 halves, aka negative 2.5. Okay, yeah, that might have just been easier. So here we have y equals negative 5 halves plus, now what's the slope? Well, the slope is asking for how much is changing, we can compute, that's just the same as f of t by the fundamental theorem of calculus. F of t at that point is -1, so we're just going to subtract off x minus 5, which is going to get us here 2. Why are there no fractions in any of their answers? Oh, sorry. Just 5. Yeah, okay. I added on the entire triangle here. I actually subtracted an extra 1/2 from this, so we actually have to add on. So instead of -5 halves, we have to use -5 halves plus 1 more half, because I forgot about this little triangle here. We're not going all the way to 6, we're just going to 5. So this here is -4 halves and -4 halves. Okay, which is just -2. So we have y equals -2 minus x plus 5, aka y plus 2 equals -x plus 5, aka y plus 2 equals -1 times x minus 5. Yeah, I don't know why they didn't simplify that up, but whatever, it's answer E. Alright. Boop, 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 boop. At time t equals 0, greater than equal to 0, a cube has volume v of t and edges of length x of t. If the volume of the cube decreases at a rate proportional to the surface area, which the following is the differential equations, could describe the rate at which the volume of the cube decreases. Okay, so edges of length x of t. So if you have an edge that is a certain length, right, you're going to have so all these edges, right, the surface area is going to be proportional to that edge squared, which is why we're seeing all of these x squareds, right? So if it decreases at a rate proportional to its surface area, all right, it's going to be answer A, because decreases, negative, proportional, some constant, and then surface area, x squared. Because if this is x, right, you have this face is going to be of area x squared. And it doesn't matter that you have lots of faces, because it just has to be proportional. All right, great. So got that? Fantastic. Next question. Let's answer A. It's not going to involve volume or time or anything. That's just incorrect. Yeah, okay. Which of the following is true about the curve x squared minus xy plus y squared equals 3 at the point 2, 1? Okay. So it's asking all about the derivative. So let's calculate the derivative. So the derivative of this implicit function is going to be 2x minus, and now we've got a product of x and a function of x. So we have first derivative of x is just 1 times y. And then now we subtract x times the derivative of y, which is dy dx, plus 2y times dy dx. Again, chain rule. You got to imagine that y is written as y equals f of x, and then the derivative of 3 is 0. Sometimes I mess up on that. You'd be surprised. But make sure you're taking derivatives of constants in these cases. So, yeah, this equals 0. So, here we have dy dx times 2y minus x, just factoring that out, equals y minus 2x, just adding y and subtracting 2x. So we get that dy dx at an arbitrary location equals y minus 2x over 2y minus 1x. So dy dx at 2, 1 is saying y equals 1, x equals 2. So y equals 1 minus x is 2, so -4. 2 times y minus x. Alright, well, it looks like this is going to be -3 divided by 0, which is always happy and always undefined. So, what is this? Well, dy dx does not exist, and the tangent line at that point. Okay, well, first of all, if you've got a tangent line that is, if you have a derivative that doesn't exist, it is because the tangent line is vertical. A tangent line that is horizontal will make a dy dx that is equal to 0. So 22 has answered D, because it does not exist, and the tangent line is vertical. Okay, so, and I'm just making sure I did my derivative calculation correctly. Also checking time. And yeah, I think we're looking pretty solid. Okay. Let's delete this. Okay, perfect. 23, what is the coefficient of x to the 6th in the Taylor series for this? About x equals 0. Okay, so here we have a function. Every time we take the derivative, so we're going to have to find a pattern, although we can just also brute force the derivative. So we're going to get the derivative of the top, which is, 6x times e to the 3x squared. Did that correctly, right? Okay. Divided by 2. So, but we don't need to worry about the divide by 2 because that's going to stay the same on all of these. So we can just imagine taking the, and this is about x equals 0 though, so that might get a little crazy. How do we approach this? This is going to get ugly quickly if we don't do this well. How would they want us to do this? Think with me here. How would you go about this problem? The first derivative is 0. Alright, well, we can do it this way. Okay, actually, let's come back to this problem at the end, just because it might be a little bit computationally intensive for us now. Let's come back to it at the end. The function g is given by g of x equals 4x cubed plus 3x squared minus 6x plus 1. What is the absolute minimum value of g on the closed interval negative? Okay, so it's either going to be negative 2, 1, or any critical points. So let's calculate critical points quickly. G prime of x equals 12x squared plus 6x minus 6. Okay, and if this equals 0, then we can divide by 6, get 2x squared plus x minus 1 equals 0. And now we solve for x with a quadratic equation, negative 1 plus or minus the square root of 1 plus 4 times minus 4 times negative, so plus 8 divided by 4. So this equals negative 1 plus or minus 3 over 4. So if we subtract 3, then we're going to get negative 1. So if subtract, so x equals, so if we subtract 3, we get negative 4 over 4, so negative 1. Or if we add 3, we get 1/2. So we have 4 points to check. Okay, so first let's check at negative 2. So g of negative 2. Well, actually, yeah, okay, g of negative 2. So we're going to get negative 8, so negative 32 plus, and then we're squaring it, so 12 plus 12 plus 1. Okay, so this is going to be negative 32 plus 25, so negative 7. Okay, now negative 1, so we're going to get negative 4 plus 3 plus 6. Okay, that's definitely not it. Could it be at 1/2? No, it's never going to get high enough at 1/2. Or at 1, yeah, we're never going to get high enough at 1 either. Okay, so it is negative 2. Oh, wait, what? Negative 2 isn't an option, though. Oh, sorry, okay. Well, x equals negative 2 is the position, but that's not necessarily to say that x equals negative 2 is the actual value. We got to calculate. It's going to be negative 7, so A. All right, and let's try to go faster. I don't know why I'm taking so long on this. I am usually blazing hot on the multiple choice section. Done with it with loads of time. Well, okay, I won't say that, but I usually have more than just 2 minutes per question, as we have now. Which of the following is the solution to the differential equation dy dx equals e to the y plus x with the initial... Okay, well, we use separation of variables. dy dx equals e to the y times e to the x, and we get that e to the negative y equals e to the x dx integral. Okay, so negative e to the negative y equals e to the x plus c. Woohoo. Okay, so we multiply by negative 1, we get e to the negative y equals negative e to the x plus c. Okay, and then we natural log negative y equals the natural log of the absolute value of negative e to the x plus c. Y equals negative natural log negative e of negative e to the x plus c. Alright, now let's do some calculation. Y of 0 equals negative... Okay, so when x equals 0, we get negative natural log of 4. So negative natural log of 4 equals negative natural log of the inside... Okay, so so e to the 0 is 1, negative 1, plus c. Alright, so just quickly here, this means, by getting rid of this, that 4 equals negative 1 plus c, which implies that c equals 5. Okay, so if we go back to our general solution, plug in 5, we get that y equals negative natural log of negative e dx plus 5, or answer C. That's correct, right? Yeah. Okay, great. Let's delete this and get rolling on another problem, so we don't hold ourselves up too long. Come on, go erase. Okay. Second. Okay, so which of the following series converges? All right, absolute value of sine n divided by n squared, that definitely converges. So you got some serious going to 0 action. E to the negative n, that certainly diverges, because you're just going to the n, going in really fast. All right, n plus 2 divided by n squared plus 2. As that approaches infinity, that's going to be the same as 1 divided by n, aka the harmonic series. So it's going to be 1 and 2, or answer D. Okay, nice and efficient. I like it. All right. And just make sure you don't mess up on the easy ones. Yeah, definitely going to answer D. All right. If the integral from 1x of f of t equals blah minus 4, then the integral of 1 to infinity of f of t dt is. Okay, so basically it's asking as the limit approaches infinity for this value. So for this value, what we're going to be seeing here is, and the answer is going to be 1b, but I just want to show you. So we're going to see 20x, and as this goes to infinity, the plus 21 in the square root won't matter, and actually it won't be what I just said. It'll be like something else. So it'll be a. So the plus 21 won't matter, so we're going to have the square root of 4x squared, which is the same as 20x divided by 2x, right? X's go away, and this is equal to 10. But then, of course, there's the minus 4 here, and 10 minus 4 is 6a. Okay. I got tripped up by not getting rid of the 2 in the square root, and that's how I got you your original incorrect answer. If x equals t squared minus 1 and y equals the natural log of t, what is the second derivative of y with respect to x squared in terms of t? Okay, classic problem. So, first of all, the first derivative of y with respect to t, that's the most important to find first, is going to be equal to, first derivative of y with respect to x equals the derivative of y with respect to t divided by the derivative of x with respect to t. Now let's go ahead and calculate that. Derivative of y with respect to t, ln of t, goes to 1 divided by t, divided by 2t. This equals 1 over 2t squared. Now, the fun part, hope you remember the formula. This is the derivative with respect to t of dy dt, or sorry, dy dx, divided by dx dt. Alright, so here we're going to have the derivative of this, and another way to rewrite this is 1/2 t to the negative 2, and when you write it like that, it becomes clear that the derivative of this is negative 2 times 1/2, which is negative 1 times t to the negative 3, divided by dx dt, which again stays 2t, leaving us with negative 1 divided by 2t to the 4th. Looks like that's answer A. Am I sure that the negative 1 is in there? Yeah, because you need this negative 2 derivative to come down. Okay. Okay, yeah, that looks good. Cool. Got 5 minutes left. Let's use it well. Come on, eraser. Please work. Eraser! Fine. Finally. got it so when I switch my pen around, it'll turn into an eraser, but it doesn't work always. I gotta fiddle with it. Okay, 23. Let's do this computationally intensive one. Actually, that one was less computationally intensive. 17 was the computationally intensive one. Oh no, this is just the arcsine one. Okay, fine. Going back to 23. This is the computationally intensive one. Oh boy. Well, about x equals 0, so what it is looking for is the sixth derivative. Oh, I bet we can frame it in terms of its own derivative. I bet that's a solution. So 6x times e to the 3x squared. Okay, so this is going to turn into, and then we divide it by 2, so, oh, come on, soft eraser. Alright, when we do this, we're going to do the product rule, but the x here won't matter, so we only need the one where we take the derivative of the x. Okay, yeah, when we take the derivative of the x, we get 3 times e to the 3x squared, which is the same except multiplied by 6. So my theory is that we're going to be, now we're going to multiply it by 3 again. Or sorry, now we're going to multiply it by 6 again. Okay, so we're going to multiply it by 6 one more time. So we're going to multiply it by 6 two more times. So we're going to multiply it by 36. And 3 times 36 is 3 times 36, 98, divided by 6 factorial. So 98 divided by, what's 6, 720. This equals 49 divided by 360. It's not an answer, is it? Well, I know it's got to be out of 120, so... Ugh. 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 I know it's going to grow. Let's assume it grows by 6 each time, so you're going to have... Alright, which one should we go for? Let's go for... It's got to have lots of 6s in it, so... Heck. Let's go for answer A. Alright, well, unfortunate. You got to do a guess sometimes. I'm going to look into what that is, though. Try to polish it up so that if it comes on the exam on the actual Tuesday, I'll know what it is and how to stop it. Alright. How to take it down. So, this one. Was that derivative of arcsine? Let's use simple implicit. Sine y equals x. Derivative of this means that dy dx times the cosine of y equals 1 means there's some way to derive this. Alright, I don't see why it would involve square roots, so we're going to go with d, 1/2. Well, when would the derivative of arcsine equal to... Okay, well, actually, the arcsine function looks like this. So, well, okay, actually, looks a bit more like that. So the derivative is going to equal 2, and it's only got to be positive, so it's going to be about here. And arcsine isn't even defined past 2, so I don't see where any roots are going to be coming into this equation. Except, oh, actually, you got a square in there. So, let's see. It equals infinity at the end. So it can't be C, can't be E. Probably isn't D. I'm gonna guess it's A. Okay. Question 14 for funsy kicks. All right, this one. So take the derivative b divided by bx plus 1 divided by 2ax divided by ax squared plus 3, and so as this all approaches infinity, 3's go away, this doesn't matter, and we're left with, okay, so time's up. So this is just for fun kicks now, just very quickly. So this goes away, b's go away, a's go away, oh boy. This leaves us with so 1 over x divided by 2x over x squared. This is the same as x squared divided by 2x squared. Oh boy. This should be b. Well, that's fun. We can't change what we can't change. Alright. Shows that you should calculate stuff better. Alright. Well, time to go to the answer key to see if it actually should be b. For all you looking, yeah, it's b. Okay. Well, hey, at least we got it right in the end. So now let's do our normal correcting. So, C, question 1. C, D, bah. I wonder why I missed question 4. Question 5, question 6, question 7. Yeah, look at all this D. Hey, so it's always good to go with your gut, even if you think that it's really weird that there are C, C, D, E, A, D, C, D, 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 E, D. So many D's and E's. E, D, on this one, even though we did get it in the end. 15 is B, then A. 17 is B. 18 is A. 19 is C. 20 is E. 21 is A. 22 is D. 23 C. 24 is A. 25 is C. 26 is D. 27 is A. 28 is A. Alright, that's slightly bad. We got 4 wrong. It's not the end of the world. We should have gotten 14 correct. I was clearly doing some wacky mathematics. Let's go see what question 4 was and why we got it wrong. Oh boy, doing some weird stuff's happening there. Alright. Question 4. Which of the following is line tangent? We got this one wrong? Oh boy, let's redo this calculation. Is it possible that I forgot to make the 10 go to 0 in the differential? I hope not. 2x minus 3y, and then product rule, okay. So, minus 3 x dy dx. This equals 0. So, I bet I made it equal 10. You know what? I bet I made it equal 10. Oh, so much silliness. So, let's see it. Dy dx equals 2x minus 3y divided by 3x. I just added the 3x and dividing by 3x. So at x equals 1, y equals negative 3, we get that 2x is 2 plus 9 over 3. This is 11 thirds. Yep, answer E. Is that what they said it should have been? I bet it is. If we go back down to what they say answer 4 should have been, answer 4 should have been E. Yep, okay. Well, it's good to know that I can get it right. Let's think about question... Okay, well, yeah. As for question 17, let's look up the derivative of the arc sine. Actually, let's see if we can calculate it maybe quickly. That would be fun. There is a way to derive it, and I might actually do a video on it at some point. It's really cool. There's a video on Khan Academy already, so I don't know. I don't want to just copy Sal. But, so there's a way using implicit differentiation to derive the derivative of the arc sine. So probably be the sine of y equals x, because this implies that y equals the arcsine of x. So the derivative of y, dy dx, times the cosine of y equals 1. So dy dx equals 1 over the cosine of y. Is that useful? Oh, could we solve this differential equation? No, because we're looking for the actual derivative. So, yeah, not so useful. Unless, actually, because this... Alright, well, you know what? This is silly of me. Even though I forgot what the actual arcsine was, I do know a way to find it. So, if you know f times the inverse of f of x, alright? So this is inverse function relationship. That equals x. If you take the derivative of this, what you end up getting is f negative 1 prime of x times f prime of f negative 1 of x equals 1, which tells you that the derivative of your inverse function at x equals 1 over the original function prime times the inverse function at x, which would have told us, because arcsine here is our inverse function. So if we had done this, what we could have said is, so f of x equals sine x. Let me change colors so it's a little bit more vibrant. So f prime of x equals cosine of x. And so the derivative of the inverse function to sine of x, which is arcsine of x, is going to equal 1 divided by, and I don't know if this would play well with the algebra, but would be 1 divided by the derivative of it, so cosine of the inverse of x. Yeah, this may not have actually been so good for the algebra, because then we would have had to set this equal to 2. Without a calculator, could we have solved this? Possibly. So, actually, yeah. So, this would be 1. So, if we take the derivative, sorry, invert both sides, reciprocate both sides, you get the cosine, yeah. So, basically, had I put my silly brain to work, we could have solved it. Because the arc cosine of 1/2 is, as we all know, root 2 over 2. Right? Wait a minute. No, it's not. Of course it's not. It is 60 degrees, so pi over 3. So now we're asking for the arcsine of x equals pi over 3, to which we say x equals the sine of pi over 3, aka root 3 over 2. So there you go. Not the most elegant way to do it, perhaps, but I bet if we scroll down, the answer to 17 is going to be B. Let's see. Ugh. Come on. Answer to 17? B. Alright. So we solved that one. Now let's just see if there are any more that we want to look into. 23. Ah, yes. The calculating out all of the different terms problem for this coefficient of the Taylor series. I don't know what you are meant to do with this problem. Calculating it out directly would be nightmarish. I feel like I may have made a logical misstep with myself. But I feel like there's a pattern. Alright, I'm going to leave it to you, the viewer, to figure that out, because we are actually running quite long here. If you want to try to figure that out, my theory, if you need a little nudge, is that if you take the derivative, you'll obviously have a a term with an x, right? So you'll have some x times e to the blah. When you take the product rule of this, you're either going to get to x squared e to the blah, you're going to get to x squared e to the blah plus, and then derivative of x, so e to the more blah, but now a constant times e to the blah. And obviously we're evaluating at 0, so this part goes away. So my theory is that then you have this k blah, and if you raise that k to the third power, because you're saying x to the 6, do that 3 times, k cubed times e to the blah, that's what you're going to be getting at the 6th term. Yeah, maybe you can prove me right or wrong. Well, actually, just quickly, if that was the case, then we would find that k is 6, as we figured out, right? So 6 times 6 times 6 divided by 2, remember? And then here we have, we also have to divide by the 6 factorial. So 0.15, is that any of these solutions? 0.15, I don't think that's 3/20ths, right? Yeah, okay. Maybe my theory is wrong, maybe I just did a calculation quickly. Anyway, I hope you enjoyed the video, and good luck if you're trying to figure out this problem. Yeah, I wish you luck. Okay. Bye. See you in the next video.